All right, this is the last question I'm working today. We've got Wasim on a Dreamliner jet flying east. The jet is capable of flying through the air at 250 meters per second when there is no wind. For an hour of the flight, there's a nasty headwind traveling at 73 meters per second. At what speed is the jet flying? All right, so this is a vector question, right? We've got the jet, which is capable of going 250 meters per second. It's going east, so that's to the east. Now it says there's a headwind going at 73. So we're going to add its velocity. This one is happening at exactly the same time, so we can add it together, going 73 meters per second in the other direction. So the result of adding those together is that it starts here and ends there. Right? We still start at the beginning. We're still adding head to tail, just like you did in the lab. All right? So we're starting here and ending over there. So we go 250 minus 73, which will give us 177 meters per second to the east. Now it does say what speed, and so the speed we can just go 177 meters per second. Done. Letter B, the next hour of the flight graciously has a tailwind of 57 meters per second in the direction of travel. At what speed can the jet fly now? Well, normally it can go 250. And then we're going to add on to that an extra, because we've got a tailwind pushing us in the same direction, 57 meters per second. And so we put those together and we start at the beginning and go until the end, and we get 250 plus 57, which is 307 meters per second. So we have 307 meters per second. Still directly east, all right, but the speed doesn't require that, all right? In the third hour, the wind changes and now is blowing directly to the north with a speed of 20 meters per second. What is the velocity of the jet now? So notice two things. Number one, the wind isn't with or directly against us anymore, right? We've got our 250. But now the wind is blowing north. So this way at 20 meters per second. So the question is, what is the velocity? Well, the jet should be flying directly east, but the wind is going to push it a little bit to the north. So what's going to end up happening is this guy right here, starting at the beginning, ending at the end. So that's what we're going to get right there for my new velocity. All right? So we know this is a right triangle. I set it up easy, so you got it going to the east and north. And so we should be able to find that. We go 250 squared and then add the 20 squared, and then we square root that, and we get a value of almost the same thing, but 250.8 meters per second. All right, so that's that one going slightly up a little bit. Now it does ask for a velocity, which means I also need a direction. Okay, so for the direction, I'm going to need to use maybe tangent here. So we're going to go tangent of theta equals opposite over adjacent. Okay, I'm going to use the actual values I started with, not the calculated value. And so I'm going to go inverse tangent, and I'm going to do inverse tangent of 20 divided by 250. I have to do the inverse to get the tangent over to the other side there, and I get an angle of 4.57 degrees. All right. So I simplified it. We don't have any weird angles. It is just 4.57 with respect to 0. So there is my answer to C. All right. Now in D, it says, Jed, the pilot, realizes that to get to their destination, they need to travel directly east for the last hour. So we've gone 3 hours now. We need to go directly east for the last hour. he turns the jet slightly so that the plane can travel directly east. In what direction should he point the jet? All right, so we still have 250, right? 250 is the capability of the jet, but we're going to point it this way now. Okay, because remember before it was pointed directly east. In question C, it was pointed directly east, and the north wind was pointing it up. Where the north wind meets. Oh, sorry, watched too much Frozen 2 lately. So we got 250, which then points upwards. So we're going to point it downwards a little bit, so that when we get that 20 pointing up, sorry, that was not 250 degrees, that was meters per second. And then this guy is now 20 meters per second, right? Because that, it does say to keep, well, it doesn't say it, but we're going to assume that that north wind is still the same. So when I add those together, it should start here and end there, right? I want to go directly east, and so this is the way to do it. Add that downward angle one plus the north, all right? And so again, I should be able to use Pythagorean theorem. I should be able to use an angle, right, to be able to do that. So for example, for the angle, I'm going to do tangent, nope, not tangent, because I have the opposite and the hypotenuse. So that would be sine of theta equals the opposite, so over the hypotenuse. And then I'll do the inverse sine of both sides to get it over there. And that should give me that theta 4.59 degrees. All right, now I need to get the other missing side. So it's going to be x squared plus 20 squared equals 250 squared. Remember, the 250 needs to be the hypotenuse there. Okay, so we're going to go 250 squared, and then minus the 20 squared, and then square root it. And when we do that, we should get that x equals 249.2 meters per second. So not that big of a difference, 249, okay, which is why airplanes aren't affected too much by crosswinds. They just have to turn a little bit, and it doesn't affect their velocity too much. All right, so we then have our velocity, 249.2, at 4.59 degrees. Okay, there you go. So we've got the direction, because that was the 4.59 degrees, and we got the velocity, which is 249.2. Awesome. Letter E asks, assuming that Jed points them in the right direction, Wasim lands at his final destination after exactly 4 hours. What is the total distance traveled? Awesome. So distance traveled, that should be easy. We had 177 meters per second there, which he's going to do for an hour. Now an hour is 3,600 seconds. So we're going to go 177 meters per second. And then we're going to do a conversion. We're going to go 3,600 seconds per hour. And they're going for 1 hour, so that should be able to give us a distance there. All right, so we'll multiply those, and that'll give us our distance. Which is 637,200 meters. All right, the next one gave us a speed of 307 meters per second, so 307 meters per second. Again, we'll go 3,600 seconds per hour, and we'll get 307 times 3600 is 1,105,200 meters. Okay, again, that's in 1 hour, so I'm multiplying by an hour. Okay, so 1 hour, so time times speed gives us distance, right? Sorry, I should have written that up there to make it clear. I was multiplying 1 hour. Okay, the third hour, it says he's going 250.8. So again, 1 hour times 250.8 times 3,600 seconds per hour. And I get 902,880 meters. And then the last hour, I'm going 250, so I get a total speed. This is the blue is what I'm actually doing in each scenario, right? That's why I use the 250.8 because that's what I'm actually traveling. Okay, so this one will be a little bit slower, the 249.2. And then multiplied by the 3600. So 1 hour times the 249.2 meters per second times 3600 seconds per hour, right? So I hope that I'm not going through that too fast. It's just time times the speed, which should equal the distance, right? And I'm doing a conversion from seconds into hours because my speed was in meters per second. All right, so then I have 897.120, 120 meters. If I add all those distances together, then that should give me my answer here. And the distance that I get is a total distance of 354 to 400. Awesome. There you go, meters. Or you could say, if we're dealing with sig figs or whatever, these numbers all have two significant figures. So really, you probably want to round it down to about 3,500,000 meters. And that's the distance traveled. All right, so that was letter I. Now we've got II for E. Okay, what's the final displacement? Which is very, very close to the same thing. Okay, we'll go ahead and draw this. I'm gonna move this all up so I can make one final drawing. Okay, so my displacement, I've got the displacement going in this direction, right? That was displacement A, which is going to the east. We already found that, so that's 637,200. Then I've got the displacement from B, which was further, right? That was 105,200. Okay, the next one is also horizontal. The D is horizontal. I'm actually going to add the D before I do the C. The D was 897, so not quite as long as the second one. 897,120. All right, now this last part, right, my final displacement is from letter C. Remember, this guy actually goes up a little bit like this, okay? So I know that it was 250 meters per second along here, and it was, actually I'm gonna do a different color for this because I'm writing in speeds now. Okay, so this was 250 meters per second, and then this guy up here, because I'm trying to do displacement, right? But I'm just making a note for myself, that was 20 meters per second. So my last displacement is not horizontal, so I need to break it down into its components. Okay, so the vertical component is 20 meters per second times 3600 seconds per hour, and then multiply it by an hour. That's still speed times being turned into hours per hour, meters per hour. Speed times time equals distance, but what it's going to give me is it's going to give me that vertical distance there. Okay, so I go 20 times 3600 and I get a vertical displacement of 72,000. And then I do the same thing right here actually with the horizontal, which is going to be 250 times 3,600. The same idea, right? I'm going to take that 250 meters per second, turn it into meters per hour. Seconds cancel out, leave me with meters per hour, and then I'll multiply by 1 hour so that it gives me the total meters, which will be 900,000. So I have a total horizontal displacement, adding all these together, right? the 900,000. I'm gonna add the 897,120. I'm gonna add the 1,105,200. And then I'm gonna add the 637,200 right there. And I add all those together. And my total horizontal displacement, when I add all of those together, is 3539520. Okay, that's what I get for adding each of these horizontal displacements together. Now I need my vertical displacement, which was 72,000, which is basically nothing, of course, relative to the rest of the distance. And so now I should be able to get two things. I need to be able to get my hypotenuse, which is the total displacement. And then because displacement is a vector, I do also need a direction. All right, so I'm gonna go ahead and give you those numbers. I want you to try to work it out, make sure you can get them. And this is the final answer, which is 3.5 times 10 to the 6 meters at 1.2 degrees. And you'll notice that the displacement here is almost exactly the same as the distance here. When I calculated it, I actually got 3,540,252, all right, which I rounded. That number is very, very close to the distance we got. It's a little bit shorter, right, because going diagonally is always shorter than taking the long way, going horizontal and then vertical. But this vertical is so small compared to that, right? We got a very, very, very small angle, so it didn't really make a big difference in terms of the hypotenuse being distance versus displacement. All right, so that's the end of that question. I hope that was helpful talking through each of those ideas. Remember to find a total displacement. You need to add together all the horizontal components. We're basically adding together the vectors. This is why we had to learn about vectors. Add together each of the horizontal pieces, add together the vertical pieces, create our final triangle down here, which is what we got down here at the bottom, and then you should be able to find the hypotenuse and the angle right there. And that's it for tonight. Thanks, everybody.